Speaking about photocatalytic coatings, I would not call it a product because this is really a technology. It's a system how to purify air, how to protect our wealth, how to protect our buildings, and how to clean the environment. So it is not really a product, it's a technology. The technology brings many new things. So yes, application is like a product. You paint it over the final paint, and you create a very thin layer, so about 10 times thinner than the paint coat, and it protects the paint coat underneath. So the paint from resin is suddenly protected by a thin layer of titanium dioxide special coating, which absorbs all the UV, gets hot, so to speak, gets a oxidative potential at 3.2 electron volts. I don't want to bother you with the technical details, but it's more than on chlorine. It's more than on ozone, and if we express it as a temperature, it would be like 30,000 degrees C, which is a higher temperature than on the sun. So anything burns on it when it's properly illuminated. So when a daylight shines on the coating, any molecule that will actually touch it will lose an electron between the bonds. So it steals the electron because it's electron deficient surface, titanium dioxide, and steals the electron, opens the bond, and oxygen, which is ever present, will just bind to the ends, and this is actually burning. It's like burning at a room temperature and a complete mineralization. So from toxic compounds like benzopyrene, which is highly carcinogenic, it's a monitored compound, you create a harmless molecules of water and CO2. Bacteria sometimes they are mutating, so they get more resistant. So in the case of photocatalysis, it's like a hot plate, so they are not able to mutate and adjust to it, so they just burn. They just survive or burn. So depending on the intensity of light, so you need some light to be present. It has to, yes, it takes 420 nanometers and down, so deep purple and lower UV is preferred. The peak is at 365 nanometers. So it's many insects see in this spectra, people don't.